we'll come back to it and treat it properly on Thursday because there really isn't enough time. But let me ask you guys a series of questions right now about Chuck-a-Luck. Okay? And you know what? Let's go up to the front board. It'll be easier to see. Okay? Then, I'm going to put... I'm not telling you that.
No,
I'm not saying don't go to Vegas. I'm saying go to Vegas smart and realize this. So here's the deal. Let's finish with this question. The question was, what is the chance of rolling, say, 2 5s? What I want to do is, I'm going to list all the possible. Let's say you bet on 5. It doesn't matter what number you bet on, whether it's 5 or 3 or 6. Let's just say you bet on 5. What would you guys assume the chance of rolling absolutely no 5s is?
With 3 dice.
With 3 dice. Out of 3 dice. Out of 3 dice. Out of 3. What would if you had to ballpark a guess? What do you think? What do you think the chance of rolling 3 dice is? Give me some guesses.
We're just rolling once, right?
We're rolling no 5s at all out of 3 dice. What do you think? Ballpark the chance.
18%.
Say that again.
18%.
18%. Ben? Give me a ballpark. Ballpark. Give me a gut. 20%?
12.
12%?
Well, it's 15 out of 18 because of the days away.
So that's 83%? Okay, 83%. I'll tell you what. Hang tight. Let's collect some data right now. Grab your TIs. Grab your TIs. Let's simulate this. Rather than rolling real dice, which takes too long, we can actually simulate this pretty quickly. Okay. Let's fire them up. You lost. Okay, everybody do this. I want to collect some quick data. Everybody, math button, PRB menu, rand int, 1, comma, 6, comma, 3. This will roll 3 dice for you so that you can see it. Okay, so far?
So the 1.
Now, the 1 and the 6. The 1 and the 6 tell you the limits of what you can roll. At least the 1, but no more than the 6.
Yeah.
And the 3 tells you how many. Everybody press enter 1 time. Now, what we're going to do is we're going to keep a running total. We're going to keep a running total of how we did. Let me count real quick. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30. That is awesome.
Don't count me, I don't have a calculator. Right here.
29.
28.
28.
27.
27.
She just leaves. Later.
Bye, Kate! 27. How many of you got no 5s at all in that 3? We're checking for no 5s. I did not get any 5s. Did I? No, I got 3, 6, and 6. No 5s at all. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 out of 27. Okay? You ready? Do it again. Do it again. How many of you got no 5s that time? No 5s at all. No 5s at all. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 14, 15, 16, 17, 18. Okay, we got 18 more out of 27. Do it again. Enter again. No 5s at all. Should have been on 6, obviously. No 5s at all. 1, 2, 3, 4, 5, 6, 7, 8, 10, 11, 12, 13, 14, 15, 16, 17. 17 out of 27. See a little pattern here, friends? See what we're getting each time, roughly? One more time. No 5s at all. No 5s at all. One more time to collect some more data. So we got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay. Now what I'm going to do is I'm going to do some kind of bastardized mathematics. I'm going to add these fractions the wrong way. I'm going to add the tops and the bottoms. And the reason I'm going to do that is because essentially we don't actually have 27 samples. We've got 27 times 4, don't we? So we actually have, what is that, 108 samples? And of those 108, how many times did we see no 5s at all? 33, 50, 61 out of 108, which is roughly 60%. Ben, there's an answer for you. You should see no fives about 60% of the time.
Guess 60%.
You were going to guess 60%?
Because you said 60-40 pretty much when we were doing it earlier, didn't you?
But that doesn't take into account. The 60-40 is the payout. That's not the probability of the dice. Nice. It's nice that it's a correlation, Matty, but it doesn't give you the answer.
All right.
Ben, is that okay? We have time to simulate. Let's simulate the other ones too, okay? Let's simulate getting exactly 1 5. Okay, this time? So again, out of 27, let's press enter again. How many of us got exactly 1 5 this time? Exactly 1. I did exactly 1. If you got more than 1, don't count it. Exactly 1 5. 1, 2, 3, 4 of us.
Oh wait, I did 2.
5 of us. Kate, do it again. Exactly 1 5. Exactly 1. Look at this. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Why am I doing more than one trial of this, friends? Why don't I just do it once and call it good? Because I need the overtime on average, and I'm not going to see that unless I do a few hundred trials. Okay? How many got exactly 1 5 this time? 1, 2, 3, 4, 5, 6, 7, 8, 9. Let's do one more.
I got 3 5s on that one.
Wait, did we count you, Matty, on that
No.
one? We didn't. Okay, good. Exactly 1 5 this time. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, there's 9 and 27. Let's see what we got. It's 5 and 12 is what that? 17, 26. This is roughly 35-ish. This is roughly 35%. So, roughly a third of the time, you should see a 1. What does this add up to? 95%. That means 5% of the time, you're either going to get 2 5s or 3 5s. Now, I don't think we'll have enough time to see these, but let's try it real quick. Let's try it real quick. Let's do this 4 times. Do we get any double 5s here? Do we get any double 5s?
Yep. I got 1.
I did too. I got double 5s in one of my trials. We got 2, 3, 4. You got 1, 3, 5s? 1, 3, 5s, Katie? So 1, 2, 3, 4, 5, 6. So we got 6 out of the 108. I'm just going to put the 6 here and the 0 here. It doesn't really matter anyway. It doesn't, right? 6 out of the 108 is roughly, what is that, about 6%-ish? Now notice we're off a little bit because of rounding. This can't add up to higher than 100%, which it is now done. But that's because I'm being pretty cavalier with my rounding. But if this adds up to just about 100%, what's left for this? Basically, there's nothing left. Let's do it 4 more times, real quick. 4 more times. 1, 2, 3, 4. Anybody get 3 5s this time?
No.
Anybody get 3 5s this time?
Nope.
No.
I got 3 5s at 1.
I know you did, Matty. I know you did. And here's the problem. It's clearly not impossible to get 3 5s. But it is definitely improbable. The question is, we haven't done enough overtime to simulate it yet. So, what we've got so far, somebody make sure they have these written down in their notes. We've got about 60% likelihood for no 5s, roughly 35 for 1, roughly 6% for 2s, and basically nothing for 3s. What we're going to do on Thursday after your guys' exam is we're going to run a computer simulation like 10,000 times to do what we just did, but do it like 10,000 times. And Matt, we won't lose your 3 5s this time. We'll keep track of 1. I didn't mean to piss you off. But we're going to get better rounding, lots less cavalier rounding. We'll get Kate involved. Kate was pissed, she left. Fair? So, for Thursday, study hard. Bring your booklet. Yes, your in-class quizzes, should you choose to lose them as a quiz, turn them in. I got a stapler, in case you want to staple it. Don't forget. I think you should. Don't forget the vote. Thank you, Kurt, for saying it again. I forgot we had that discussion. We'll see you guys Thursday. Email me if you get stuff. Tiffany, what's on your mind? It was negative 0.6. That's what our average came out to be, negative 0.6.
His and mine were the same.
That's
So I
okay.
put his name
Why am I
on-
recording it?